The last summer in Israel was not just typically warm, it was also quite intense. I remember sitting one morning in my study working with a colleague. The dog comes in and hides below the desk. The dog, she was always the first one to hear the sirens. We look at the cell phones and we see a notification that indeed we are being shot at from Gaza with missiles through actually a system by Vigilo, one of our portfolio company that does public mass alerts in Israel. We wait about a minute or two, hear two large explosions as Iron Dome intercepts the missile, smile between the two of us, and go back to work. Iron Dome in Israel not only saved many lives, it changed the morale of the whole population within those few hectic, intense weeks in the summer of this year. The existence of Iron Dome is not only saving the lives, it's allowing the governments, allowing the leaders to take more measured measures, to take more time in responding, and thus not only saving the direct lives from those attacks, but also many more potential lives on both sides, on our side and the Palestinian side. Our next keynote speaker is Dr. Danny Gold, the initiator of Iron Dome. Dr. Gold holds two PhDs, not one in electronic engineering and one in business management. He won the Air Force prize, prestigious prize, not once, but 4 times. He was nominated, he was named prestigious defense technology associate by Singapore. And in 2012, he won the most prestigious Israeli defense prize for his initiation and management of the Iron Dome system. So it's with a mix of great honor and gratitude that I'd like to welcome Dr. Danny Gold, initiator of Iron Dome, to stage.
Good afternoon. Thanks for the nice presentation of me, and thanks OurCrowd to inviting me. It's my pleasure and honor to be here. What I will do, I will scan, before diving into the Iron Dome, I will scan through other technology that we are or have developed in the Israeli Ministry of Defense and in the industry of Israel, not just defense industry, and try to connect this presentation and after that Iron Dome to what you are doing here. So, of course, as you know better than me, a few years ago, 10 years ago, we have given the operational demand or the market need in the commercial wording and went to develop the technology. Together is not anymore the reality. The reality is the technology challenge to create or find or expose hidden market needs, or in a language of operational channel, hidden operational needs. I give you some examples of what we have done in Israel, starting with the attack. This is the F-16. Normally we buy the F-16 for US, and we don't need the music. But we replace almost everything inside, with the brain, the command, control, communication, the cyber, electronic warfare, missiles. And this is missile developed by Israel, long, medium-range missiles. His uniqueness is it's going to the target without using GPS. GPS will be jammed in work, like, by the way, jammed today in a boat race near Cyprus, and it's very easily to jam GPS. So what the system is doing is autonomous weapon, have his own eyes, own sensors, look at the ground, very sophisticated sensor and brain, look at the ground, compare what you see on the ground all the way to the target. For a satellite photo, inject it to him from satellites in real time. Like I'm going home, I'm not doing GPS, I'm turning right near the grocery store, he's doing the same, tracking roads, valleys, hills, going directly to the target with no using no aid. Very precise, much more precise than GPS without using GPS. Of course, this technology haven't been developed only for this. It was developed through automatic target recognition of object, of suspicious object, of target. Commercial world, of course, is a lot of applications, starting with security, indoor and outdoor, automatic recognition of suspects or object, and of course, ending all the video matching and the video processing, what Google is doing and others is doing, both for commercial, advertising, in real time in internet and other things. This, by the way, is one of the, I hope, will be one of the boosts of technology that will go outside, out of the defense industry to the commercial world, by people or by some arrangement. Another example is, I call it, it's not cyber, it's called electronic warfare. I will show you in two movies. Electronic warfare is like cyber, but much more complicated than the cyber in the network. I give you one example. This is F-16. Everybody is going to the target, Iran, Syria, Iraq, never mind. Everybody want to take them down. This is the enemy MiG-29. From the ground, they want to take them down by ground-to-air launcher missiles, like S-300 or others. And he have a system called electronic warfare, or cyber, more or less. Automatically sense what is going on around him by special sensor, locate, exactly geolocate, who is threatening him as the resolution, very high accuracy, present to the pilot, of course, in two-dimensional, three-dimensional, so it will be easy to operate, and semi-automatically launch missiles directly to the geolocation of the target. Before they move, we can destroy the threat, remove the threat. And another system, which is real like cyber, but much more complicated, is wake up immediately. I mean, nanoseconds, okay, immediately in the aircraft, transmit to the air viruses. The viruses are coming to the incoming missile, penetrate the missile head, which have a lot of protection, like firewalls and abnormal behavior and everything inside. We call it electronic warfare. Penetrate all of this, bypass all of this protection, hit specific point, and you can see the missile missing the target. I will show it in another application in protecting a commercial jet. You know, there's very in the terrorists to try to shoot down commercial jet, like El Al, United Airlines, try to shoot them down. They have tried to shoot El Al in Mombasa a few years ago. They are shooting once in a while around the world. So this is, let us say, this is the enemy, I mean the terrorists that want to launch, show the launch ground-to-air missile to a commercial jet. We have a system on board now installed in El Al, developed also in my organization under me, that sense what is going on, send in real-time laser, pinpoint to the head of the target, so you can see the missile missing the target. It's finished right now, the development, and now is installed under installation in El Al aircraft in Israel. And going to the digital world, you know, we have a problem, not just us, but we have called tunnels. They are digging tunnels between Gaza and the south of Israel. In the past, both for smuggling weapons, merchandise, ships, cows, women, and today they are smuggling. There are terrorist teams coming through the tunnels, pop inside Israel, and try to commit terror act. And of course, there are underground town in Gaza, in Lebanon, probably in Iran. So this is an example of underground robot from the eyes of a robot that's crawling inside one of the tunnels, mapping the tunnels in very high accuracy by beams of laser, like Google is doing, but much more accurate. So and it's not an artwork, it's like an artwork, but it's very nice. So it's sending the picture in real time back, so the video back, or this laser video back, so the forces can prepare to what is going on inside, or the swarm of robot after that can prepare what to do. Another example of the digitization, you know, we have the digitized army. We are leading the world, something called digitized army, which means the soldiers or the officers, whether they're in Gaza or in Lebanon or in Syria, or out of Israel, controlling or managing the battle, they conduct all the battle with digital world. They have iPhone, they have iPad, wearable computer more or less, and everything injected to them. They also inject information, maps, orders, debrief, who is shooting at you for what direction. It's working very good, very well, even in the last two conflicts. And now we are moving to 3D, three-dimensional fighting. This is example of mapping of, this is Gaza in 3D, very dense as you see. If we have UAV is drone, unmanned area vehicle, with sophisticated camera on board, we can see where our UAV is looking at, exact house where it's looking at, and we can see inside even, we play the video inside, so the commander can see everything. If you have two UAV, we have two videos, watching at the same car, by the way, probably a terrorist leader car. Before we take them out, we explode the car. We want to make sure that nobody is around and it is the right car. So everything is managed in 3D on a resolution, very high resolution, very high accuracy. Gaza is not exactly a Washington, D.C. highway, very dense buildings you cannot miss. So this is the next stage. And the new thing that is this is used because they are very fast. All the world is very fast. The targets or the terrorists pops up the ground, shoot, and going back to the ground or to the houses. If I look to this direction by UAV or ground forces or air force, he's shooting from them. I'm looking to there, he's hiding. So I want to control all the city, all Gaza or all West Bank or all Lebanon, or at least major part of the city, control all the time in video, record all the time in video, like the Big Brother. So this machine, this sophisticated multiple camera control an area, can be placed, of course, on UAV or on manned aircraft. Everything is, all the city is recorded in real time. Of course, I can put open multiple video to see what is going on around the city. But also, a plausible example can be, let us say I'm controlling a city. I mean, the UAV is controlling a city. Suddenly, there's a bomb, explosion of a bomb. We open immediately the video at the right point. We can see bomb few seconds ago have been exploded, aim to stop a car, and the terrorists come out of the bushes, kidnap soldiers or a civilian, back to the bushes. You can see the small, here the terrorists coming back, and we can track them back. The car, this is a getaway car, the replaced car below the trees. We can track them back to the houses or to the shelters and solve the issue in a minute. Of course, there's a lot of commercial application regarding managing the city or reduce the crime of the city. You put one above Jerusalem or above Tel Aviv, you can reduce the crime or also manage the city from well-being point of view, not just from a disaster point of view. And going to, by the way, I'm in the board of Israeli Brain Technology also. We adopt a lot of brain technology. This initiative was initiated by Shimon Peres. We have the aim of this IBT, Israel Brain Technology, is to be among the #1 in research, but also in the implementation. Startups get of the ecosystem of producing things regarding the brain, either from Alzheimer, ADHD disease, ending with brain-machine interface and commercial and military use. So we have its own map. It's been working, but talking about the robotics and brain, so small. Again, we are fighting in the urban environment, not anymore in open area. We have to go into the city, into Gaza, other city. So we develop a series of robots, small robots that can help the fighting forces or replace them. This is a robot can climb stairs, go into the room, take a very good video, send him back, so the forces can know if there are underground tunnels in the building, or terrorists are inside waiting for them, or there are explosives waiting for them, what to do. And by the way, this can climb stairs. I was sitting when I was the head of research and development. Now I'm already out of the army, of the defense forces. They have to have more money. You know, it was a startup, have to have more money. I said to them, okay, you get more money, but you have to climb 6 stories to my office to ask for money. He did it, and get money. After that, I moved to 16th floor with elevator, so easy to press. But so this is one example. And even smaller robots, this is a snake robot. They can crawl in very, very small places in the sewer, everything. Of course, the real snake. This is the robot snake. Have a very good high-definition camera. And in each section, we put other sensors. I cannot tell you what exactly are the sensors. And in the future, we will put, of course, explosives. So if it's coming to the area and crawl and see something which is worthwhile to eliminate, he will do the job also. This is and going to the bigger robots, I'm showing you this because all of this probably, I hope, will find their way out of the commercial world, including startups or more bigger company, because it's very high-end compared to even to the commercial world, and it's just the things that I'm allowed to present. Of course, there are other things. This is a robot patrolling along Gaza border instead of teams of soldiers, of course, saving lives and even do the mission better than the soldiers, not tired at all, not always alert. Send all the information of the sensor back. He's driving along, nobody is joysticking him. There's not remote control. Stop, bypass obstacles, see something wrong in the fence, stop, investigate what it is. In the future, we will put weapon on him because they are very fast. When they come to the border, they can conduct also fight. And talking about this, we go to the naval arena. Naval arena is the same. This is the last, before I go to the Arundel. This is unmanned ship. Nobody's on board, equipped, starting with a speaker that I can speak from the shore to warn a suspicious ship, whether it's an innocent ship or whether it's ship loaded with explosive, aimed to explode near our new gas installation in the sea, or near our ship, or loaded with a terrorist, want to come onto the shore, go into Israel and commit some terror act in one of the kibbutz or towns, like they have tried to do in the last conflict. So first warn, and then all this ship equipped with a lot of sensors, day, night, laser, everything that's needed, very high-end, long range, high resolution. And this ship also equipped with a gun, with munition, so we can do the job also. And this ship specifically have already sunk 3 enemy ships loaded with explosive. So this is more or less the scene. Again, there are thousands of technologies. I was the head of research and development, like a huge VC. I have 1,200 projects under me. Some very, very, very early seed, some more mature like Arundel, all together. Now I'm going to the Arundel. Arundel, the starting of Arundel wasn't easy. And I'm very modest. Everybody object to the project. When I entered the job, 2004 or 5, to head the head of R&D, everybody and people started to get killed from rockets, not in a massive number, and they didn't shoot 200, 300 rockets a day, but still was there. I thought to myself, there's no way we are not going to solve this problem. Attack, intelligence, and defense, and interception. They say to me, no. All the hierarchy in Israel, I won't say names, all the hierarchy say no. Why? Because all of the world, and also in Israel, both industry, both the government and others, thought it cannot be done. From technology and science point of view, cannot be done. People failing around the world, even in Israel, but mainly out of Israel. Reagan closed a few years ago the Star Wars program. No, cannot be done. This is one reason. The other reason, they didn't focus the future, that the threat will be a strategic threat. And another thinking was, again, huge project, 20 years, billions of dollars, nothing will get out of this. I thought differently and went into the room. I remember to say to myself and later to my team that we are going to start to do it tomorrow, somehow. I don't care. To do it, again, you have to have money and authorization. Leave the authorization bureaucracy aside, but you have to have the money. What I did, after creating the architecture, we approached the industry, get some 24 suggestions, we ruled them all out. We create architecture, give it as a sole source to the leading company of Israel, Rafael, because they're the missile house, IAI, because they are sensors house, and another small startup company from the brain for the data, for the big data and SIG2, called Empress. Now they're not small anymore. I took the chance with them, but I didn't have the money, so I told the industry I will put 7 million out of my VC money, okay, which is not accustomed to do because you will put $7 million, we have 14. We start to work together. Give me 2 years to get $200 million from the government to finish the product. I mean, from the research, I want to do all of those once. Although it's risky, very high risk, I want to do everything from the research, basic research, technology demonstration, full-scale development, production, assimilation in the field. 2 batteries, substantial amount of missile. This was my goal. And so we took it like that. Again, it took me 2 years to convince the government to give me all the money. In parallel, I didn't trust back then the government will be quick enough. Trust my government sometimes, but not to be quick enough. So I prepared private investors from US to invest in the system. Private investors that we have some good exit with them, commercial, dual use, commercial and defense technology, which is also connected to what we are doing in your organization. We take some commercial technology from the fiber communication. We adapted it to navigation, and when we returned back the outcome to him, he did an exit 10 times of his money, so he trusts us, one of them. But for my luck, they didn't have to use them. The government give me the money. Now, of course, everybody know what is the necessity of the project. The shoot in 2012 around 1,500 rockets on Israel. Iron Dome was there, protecting Israel, prevent war. Now they shoot around 4,500 rockets on Israel. Iron Dome was there. The main contribution, by the way, of Iron Dome, of course, is saving life. This was guiding me, saving life of Israeli citizens. Strategic size, of course, defense. Number two, as have been said before, is giving the political echelon or the higher decision maker time to think, room for maneuvering. They shoot at you, never mind who started, like in the kindergarten, you or them, but you have time to think. Iron Dome may give you a safety net, not 100%, but you can think. You want to go to war? Okay, you are prepared to go to war. You want to activate political power? You can do it. You want to do some special operation to take down the leaders? You can do it. You have time. You just have to be wise. And number three is money, of course. The system is not very cheap, always the cheapest missile system in the world. I will talk about it later. But it prevents billions of dollars of damages of properties, not shutting down Israeli economy, like in 2006, and of course preventing full-scale war, which is $1 billion a day. This is more or less summarizes the contribution, and of course the moral of the people that are very happy. It's also important. They started by shooting small rockets, improvised rocket that you can do in your kitchen, download the recipe for the internet, more or less. Started like that, very fast, they put, shoot, and run away. Of course, they are smart. They know we have very good intelligence in controlling almost everything what is going on in our neighborhood. So they are camouflage, hide. The launcher, this is multiple launchers from each one. They shoot missile, is in a commercial truck. It's inside, they close it, you can see nothing. Or they can dig bunkers. They dig in bunkers, holes, put the multiple launcher inside, close it, and all of this installation is below trees, so it's very hard to detect. And so some very nice movie from Lebanon too. This is some town in south of Lebanon. They are shooting rockets for 5-story building from the 4th floor. From one of the apartment, you can see the missile going out. So what you can do, what Israel can do, we can send fighter aircraft F-16 to take down the building, easy, but there are people, civilian, in the 1st, 2nd, and 3rd floor. So we cannot do it, ground forces, it's too far away. I mean, it takes time. So in this case, we solved the problem by sending specific technology through the window to take care of this problem, but they are very smart, they are learning. And of course, they have bigger rockets than that. This is 20 to 40 kilometers range, was shot at the Ashdod, Ashkelon, south of the city of Israel. This is 45 kilometer range, was shot at Beersheba and surrounding. And this is 75 kilometer range, very heavy missile, was shot at Tel Aviv, Jerusalem. These places, very heavy, Iranian made. This is not Gaza made, Iranian nice production line, but from the background knowledge of China, Russia, and North Korea, but now Iran made it very good. Very heavy missile. This missile land in the middle of Tel Aviv or in Jerusalem, probably 7 to 100 meters around him, and people will get killed. Dozens to hundreds will get killed. Now, I show you some summary of the threat.
In recent years, thousands of Qassam and Grad rockets have been fired upon Israel from the Gaza Strip. Hamas upgraded its arsenal by acquiring Iranian-made Fajr 5 rockets. The Fajr's 90-kilogram warhead stands as Hamas's largest and most lethal threat. Within its range of 75 kilometers lies the largest population center in Israel, the Tel Aviv metropolitan area.
Palestinian militants firing more than 70 rockets into the Jewish state. Israeli leaders have said they will not tolerate the increasing stream of attacks emanating from the Gaza Strip.
This is the underground launcher. You see, open, launch, massive firepower, and close again. Now I'll show you some clip that is not easy to watch. What happened before the Iron Dome, before the interception system, even today, where Iron Dome is not anywhere in Israel, happened today, but mainly before the Iron Dome, was shot in Sderot. Sderot is the southern town in Israel, very close to the border of Gaza. This is a festival of kids. They're asking him some questions about the festival. Suddenly, there's the alarm. The missile is coming in a few seconds. They have only 15 seconds or even 10 now to go to find a shelter because they are very close to the border. So this is the threat and what happened before the Iron Dome. Skip some of the technology because of time. The system, how the system is working, I skip also the multi-layer defense that we have. What the system was developed in a very unique way. Before going into that, I will show you some of the reasons why people thought it cannot be done. Speed. Running, number one, is around 9 point something seconds for 100 meter. Baseball, 160, 170 kilometers per hour. Tennis is around, the speed is 200 to 250 kilometers per hour. It's not anymore this guy, it's another guy. Of course, it's the speed of the ball, not the player. And bullet from a gun is 1,500 kilometers per hour. And rocket, even not the fastest one, is reaching 2,500 kilometers per hour. And our missile, Arundel, is also very, very faster. So they're coming to the engagement, running to each other, flying to each other at the combined speed of 5,000, 6,000, 7,000, 8,000 kilometers per hour. Very, very fast and in very close range. Very, very fast. I mean, it's a game of seconds. And even the last, we call it the end game, the last game that they're playing together, is much less than a second, and everything has to work. The sensor of the ground, the command and control, the radar, the missile, of course, the brain in the missile, the sensor of the missile, the explosion, the chemical element of the explosion, the calculation, the big data analysis, everything, much less than a second, and everything has to work, because otherwise people will get killed. This is one of the reasons people think it cannot be done. The development of the system, where I decided to develop it for the perspective of a civilian, not a military. Military, I have to protect military camp, Air Force base. I can hit the incoming rockets, deviate 200 meters away, and I'm also very, very complicated to do, but I'm okay. The military is not, the base is not big. Runway can continue, aircraft can continue to take off. Everything is okay, and I don't have to be very good also. High percent of success because they are soldiers, they know how to hide, they have shelters, they are trained. If I would protect Jerusalem, and instead, let us say missile is aiming to this hotel, and I hit the missile, deviated 200 meters away, I did nothing. Someone else will get killed in another street or another hotel, so I have to explode the missile in the air. It's a technology of sensors and explode very high technology, how to transfer my energy, I mean the missile energy, to the rockets, inside the rocket, and explode the rocket, any rockets that exist, very high technology, and I want to protect big cities, 10 on 15 kilometer city, 20 on 10 kilometer city, big city, one battery. This was one of the major obstacles. So other technique that we deploy in the system regarding, in your language, I don't have to call it big data analysis in real time, but is something like this. This is real debriefing, real recording. This is Gaza. This is the border of Israel. And this is Ashkelon, southern city of Israel. We have an oil refinery in Ashkelon. They shoot 4 rockets, the colorful one, in order to exploit the oil refinery and creating a big damage to the oil refinery and to the citizens of Ashkelon. Arundel, the black one, the black missiles, knows immediately, somehow, by very massive calculation, that only 3 of them are going to hit the target. The 4th of them is going to fall into the sea. So we send only 3. Why to waste money and create noise in the air, the aircraft, UAV? We send only 3, each one is going to his own target, and the 4th, let him fall into the sea. It's turned out to be very good technique because till now, 70 to 80% of the missile miss the target, either fall in the sea or either in open area. So we save a lot of money and noise, of course, create less noise. The system is working like a huge robot. Everything, almost everything is automatically, can be even full automatically. You just draw on the screen. It's more than a computer game even. Draw on the screen what you want to protect. You want to protect Tel Aviv? Okay, you draw some shape around Tel Aviv, around Beersheba, around Jerusalem. System tells you, optimization, where to put the element, launchers, where to put the sensor. This is a radar that transmit RF, radio frequency, to the air. We have other sensors. Brain, you can choose the brain anywhere you want, of course. And then you press a button, the system starts to work. The sensor scans the sky, detecting incoming rockets, immediately calculated if it's going to fall in the open area, we neglect, the system neglect. If not, automatically the right launcher and the right missile has been chosen, right timing is optimized and choose where to launch exactly. Missile is going to the right direction, open his own eyes, own sensors, multiple sophisticated sensors, own brain, multiple brain, all in real time. Go to the target, acquire the target, find the target, and do what you have to do to explode with the target. This is, of course, animation. I will show you some few real movies. So this is the explosion. I'll show you some very unique video. We put a night camera. Night camera can, IR camera, infrared camera that can see at night very good, can see also at day very good because of the heat. This is the sun. This is free. Incoming rockets. Iron Dome knows immediately that the middle one is going to fall into the sea. So we send only two very fast, automatic, of course, not someone not calculated nothing. Two fast one. The first is going to his own friend, explode with him. The second knows he shouldn't hit the middle one because he's going to the sea. So he bypassed it in real time and hit the right one, which is a real science fiction. To see it even in 15 at the same time is even more complicated. Now, what happened during the war, people have been told from the government to go to the shelter. We have a separate but connected, it's part of our dome alarm system that immediately again knows where the missile is going to fall. Somehow, we're calculating a huge amount of data in real time, and we can alarm only the specific location where the missile is going to fall. The rest of Israel can go to war, as you have said before. So, but people have to go to the shelter because no 100%. So, but after people saw the success rate of Iron Dome, not by numbers, above the heads, this Star Wars above their heads and everything is working, the part of them didn't go to the shelter, take the iPhone, go to the balcony or to the street and take very good videos of the interception, upload to the YouTube. So the best movies are not in the Israeli Ministry of Defense, are in the YouTube. To Ascan, I brought the best one. I will show 2 or 3 because of time. So this was the situation. First one, this is the battery. This is the launcher of the battery, okay? The battery is spread, of course, very close to the house of the civilian. No issue with that. There's an alarm, detection. Iron Dome is being launched very fast. The missile decides by himself to go back to Ashkelon, back to Israel, go down to the ground. He decides. Nobody tells you what to do. And suddenly, like he ambushed the incoming rockets, suddenly do a fast maneuvering to catch the rocket in the air. The explosion will be here in 2 seconds here. Why did it? Even for me, inventing the Iron Dome, I find hard to explain what he thought, because it's very complicated, as you know. He knows 2 things. I'll make it very simple. You have to explode the missile in the air, not to hit him. So I know exactly what is the incoming missile, where to go, what sensor to activate it, how to explode, how to maneuver to reach to the optimal point. And you have to protect the city, 10 or 15 kilometers, all the city, not just a small part of the city. This was, part of the algorithms, and then connect to your business. Science and technology couldn't cope. So part of the algorithm on ground and in air, we took from the human body, of course, the brain, and the brain, of course, and others we took from human body itself, the genetic algorithm branch. Okay, the same algorithm that part of the machine learning, business of the machine learning on cyber or machine learning on data, on big data, not exactly the same because we have to do it in real time, in very fast real time, not in a day, in, I don't know, 1 millisecond, even less than that. All the calculation, 1/1000 of second. So this is, all of this is done in real time. Another example, I will show you night interception, also very fast. So I'll try to explain. They're taking credit, of course, for the good video that they upload to the YouTube. And you will see first the second missile, second Iron Dome. This is the second one. The first one is coming from here, intercept the first incoming rockets. And the first one is going again to the Ashkelon, to the city. And going up now, 90 degrees. The shouting is the people that are very happy, of course, because the... And then I will show you two, I think, movie. One is Tel Aviv. Tel Aviv, I also was in trouble because I was interviewed many, many times on the news, even during the first shot at Tel Aviv on one of the nights, and everybody was hysterical. Yes, no, Aaron will cope with this. I will, of course, easy, relaxed. And after that, they asked me what you are doing when you hear the alarm. I'm leaving Tel Aviv. So they put me in trouble. I already was a civilian, but they put me in trouble. If I say I'm going to the shelter, people in Israel, and it was Channel 2, high rating, everybody would say, the inventor of Arundel is not trusting his own system. If I will say, no, I won't go to the shelter, I'm not going to the shelter, a not good example to the public. So some I maneuver my way out, but practically I was running along the beach of Tel Aviv, but of course I didn't stop to run. So this is an interesting story about Tel Aviv. In 2012, they shoot 1,500 rockets on Israel. They didn't shoot at Tel Aviv. We have only 4 batteries. Now we have 9, coming close to 10, and all in south of Israel. Suddenly they have started to shoot at Tel Aviv, the deadly rockets, the big one. So the first one have landed in the sea of Tel Aviv, opposite the hotels. You know, there's a promenade and the hotels, opposite Dan hotels. I know because my business colleague from US was sitting in the lounge and drinking some wine. Suddenly they saw missile falling inside 100 meters from them, inside the sea, near the beach. Of course, the hotel was empty after that. But in that night, we improvised another battery. Battery can protect the city, very sophisticated one, from the test ranges, from the R&D facilities. In one night, we assemble everything, new software, everything. We train the people. And the second missile, even before they have time to make coffee, the second missile was intercepted. And this is something was pictured again by iPhone. This is the second interception. Back then, Tel Aviv people weren't so trained. They hear alarm, they think what to do, stop to play volleyball. Also, good Tel Aviv, you know, 24-hour city, pubs, bars, stop to play volleyball is an achievement. And they go to either to a shelter or underground parking lots. And part of them have decided to hide near a wall. The promenade of Tel Aviv have a wall. Their decision near the rental bike project of Tel Aviv, the green one. And I brought this movie not because of the anthropological difference between south and the center of Tel Aviv, because the one who took it managed to take a picture of the interception here above Jaffa. Jaffa is a little bit south than Tel Aviv, connected to Tel Aviv. Here, I think here in about a few seconds you will see the interception. Here, the interception was here. And people are very happy, of course, slapping heads. By the way, the contribution, from the achievement was, again, now people are studying how we did it, was finish the business in 3 years. This was my decision. You finish the business from research to implementation and success, production in 3 years, starting from zero. And in 5% of the cost of any other missile system in the world. There's no such a system, but other missile, you know, in the missile industry, Patriot is $2 to $5 million. This is $50K, $50,000. And the development also 5% in 3 years, and top performances. Probably you know, investors in high tech, that there's an equation that cannot be solved by the books of project management, high tech management. We solve it. We change the project management methodology. We change the high tech think methodology. It's like we take in 15 startups, but not application in iPhone, which I respect, but it's not at the same complexity. Each one is, I don't know, batteries, electric cars, all have to finish in 100% in 3 years. in 3 years, and all have to work together in integration. So of course, it's the new management methodology. And now, before going to the last and the best video, again, just remind you what happened before the Iron Dome. I'm sure you are not. This was the situation back there. And now I show you what happened after the Iron Dome, again in another place in Beersheba. We call it the Arundel Wedding. It's the best video, not just in YouTube, around the world. I believe was taken by the photographer of the wedding, because it's high definition. Has been smart enough to point his camera to the south when he heard the alarm. I don't know him, but probably. We call it the Arundel Wedding. There's an alarm. You see people, not hysterical, going easy to the shelter, continue to party. Barbecue smoke is still on. Music is still on. Arundel knows already that 15 rockets were shot at the same time in order to break the Arundel. 15 salvo, 15 at the same time, 15 to the same place. So, but Arundel, take it easy. You know exactly when to shoot it, what to do. He used 2 launchers. His decision, the robot decision. You will see the first missile coming from the left, from the right launcher, here. The second from here. The third is from here. The fourth is from here. Each one is going to his own friend, explode with him. You can hear the music, by the way. And we'll Arundel launch another 15 Iron Domes missile, because there are 15 in the air. So each one is autonomous, like a robot going to his own friend. It's again like a science fiction. Even to me was we show it again. It's like they get. Thank you. It's like you get free fireworks for the wedding. It's a little bit expensive, but they are not paying. This is I think this ends my presentation. Thank you very much. Thank you.